Hi students, now we are going to solve some problems called as train problems. There are different cases in solving the train problems. The first case is the trains crossing stationary objects. These stationary objects are like a lamp post, trees and a man. These are all at rest, okay, resting objects. They are also considered to be small points comparing to the length of the train. Now you can see that this is the front portion called the engine of the train, and this is the last vehicle. LV means last vehicle of the train. The distance between these two is L, the length of the train. So L is the length of the whole train and its speed is S. The train is traveling with a constant speed S in the forward direction. These objects are considered to be point objects. So these objects are considered to be points because they are all at rest. So their length, their size is considered to be small. So these are all represented by small dots. So when the train is going to cross these objects, first which portion of the train is going to cross them is the engine. So the engine has to reach the point first. Then the engine will cross first. Next, these 2, 3, 4, 5 like that, all the coaches will cross the same point, and finally which portion will cross is the last vehicle. So the total length of the train has to cross the point objects, namely lamp posts, trees and stationary or resting man. So in this case, how much time this train will take to cross these objects? In most of the problems, the time will be asked. So I will take that speed is equal to distance traveled is equal to the length of the train, is it not? And divided by time t. Therefore, the time taken by the train to cross these fixed or resting objects, the t must be equal to length of the train divided by speed. So this is the very important formula. So L is the length of the train and S is its speed. So the time taken by the train to cross completely the lamp post, the train or a standing man, understand? Stationary objects called point objects is T equal to L by S. This formula we are going to use to solve most of the numerical problems. Now case 2, the trains crossing once again stationary objects, but objects of certain length. Sometimes the train will enter the railway station and it will cross the platform of the railway station and go away. So the railway platform sometimes will be equal to the length of the train or sometimes little more than the length of the train also. So in that case, I will take the length of the train as L1 and the stationary platform or bridge, railway bridge of length L2. Okay. So once again children, you see the engine of the train up to the last vehicle is the total length, is it not? And the stationary platform is having a length L2. Now, when the engine crosses the left end of the stationary platform, after that the engine has to cross the right end of the platform, and till the last vehicle approaches the end of the platform, the total distance now crossed is equal to L1 plus L2. Understand? L1 plus L2 is the total distance between the end of the train and the right end of the platform. So this much total distance L1 plus L2 has to be crossed. So here also let us take the speed of the train is now L. S. Speed of the train of length L1 is S. So in this case, now the speed of the train S must be equal to the distance travelled is L1 plus L2. The total distance has to be travelled is L1 plus L2 divided by T. Therefore, the time taken by the train to cross the entire platform T must be equal to L1 plus L2 divided by S, where S is the speed of the train. So this is once again a very important formula to solve many of the problems. Okay, what is the third case? Two trains crossing each other, or a train which may cross a man walking forward or reverse. So, man is walking side to the railway track, either opposite direction to the train or along the direction of the train. So all these are covered at the same topic only. Two trains crossing each other, two moving objects crossing each other. Understand? So the train, you take the same train here. It is the engine is to the right and the last vehicle is to the left. So the train is traveling from left to right and its length is L1. And another train here I have taken, its engine is here and the last vehicle is here. So this train number 2 is moving from right to left. So in this case, I will take the first train's speed as S1 and the second train's speed as S2. Okay. So in this case, S1 is the first train's speed which is traveling from left to right. And S2 is the speed of the second train which is traveling from right to left. So they are moving in parallel tracks but in opposite direction. Already we have studied relative speed and relative velocity. So the relative speed of both the trains moving in opposite directions will be what? S1 plus S2. Understand? So how much time the trains will take to cross each other? The time taken by both the trains to cross each other will be equal to what? Distance by speed. So the total distance is the length of the train. First train is L1 plus length of the second train is L2. So the total distance covered by both the trains will be equal to what? L1 plus L2. And since both the trains are moving in opposite directions, the relative speed must be equal to sum of the speeds S1 plus S2. So this is the expression to solve and find out the time taken by the two trains to cross each other when they travel in opposite directions. And the last case here, you can see that this train is having a speed S2 and the second train having a length L2, let us assume the same length only. Its speed is S2 only here also, but the direction of the second train is also from left to right. That is the same direction as that of the first train. So in this case, the relative speed of the first train with respect to the second train is S1 minus S2. Okay. So I can write here the time taken by both the trains to cross each other. No, that is T equal to the total distance is L1 plus L2 here also divided by S1 minus S2. Okay. S1 minus S2. So this is in the case of two trains traveling in the same direction. Now, in case of the second train, I can consider a man walking along the direction of the train or opposite to the direction of the train. A cyclist, a motorbike rider, understand? Or another car traveling in the same direction or opposite direction. In all these cases, the same two formula only we are going to use. So, my dear students, once again I am reminding that the first case trains crossing stationary point objects of size very negligible, like lamppost, tree, man, which are stationary. So the formula is time taken to cross is length divided by speed, and that length is the length of the train. Similarly, when trains crossing stationary objects of some definite length, okay, appreciable length, like a stationary platform, railway bridges and all, okay. So then time taken to cross the platform is T equal to L1 plus L2 by S, where L1 is the length of the train, L2 is the length of the bridge or platform, and S is the speed of the train. And when two trains crossing each other in opposite directions means the relative speed is equal to the sum of their speeds, and when they travel in the same direction means the relative speed is the difference between the speeds. So these are the formulae we are going to use to solve the problems and be ready to solve the problems.